All right, so I'm going to record this in stages. So here's an example of one of the problems in the book. You get two batteries, whatever, put together for whatever reason this way, a 5 volt and an 8 volt. This is point C and point D down here. This is node A and node B. And so in this system, you've got the Kirchhoff's law going that direction. Down here, you go, they're going this direction. And so when you think about this, all right, so at A, you've got current coming in of I1, got current coming in of I3, and then you got current going out of I2, and that's a total of 0. Otherwise, you have a problem. Where'd the rest of the current go? Clearly, it's either coming in or going out. Same thing is true at B. You've got 2 coming in, 1 and 3 are both going out. That's what I show here. And, of course, equals 0. And then you've got 2 circuits going on. You got this bottom circuit like so. So that's DABD. So that's V equals IR. So V equals IR. So we got 5 volts here. The voltage drop across this guy right here is, oh, I'm sorry, that's the top. Wait. Oh, I got these bass-ackwards. I'm sorry. Well, these are bass-ackwards. This one belongs up here, and this one belongs there. It's weirding me out. Anyway, so we've got 2 times I2, because that's the resistance and the current, and then 1 times I1, and of course you get 5 volts there, total voltage drop, and then 4 times I3 plus 2 times I2 equals 8, and there you have it. So what you've got is you got these 2 guys. These are the important ones, and then you need a third one of these guys. I chose to use this one. Okay, I have 3 unknowns, 3 currents that are unknown. I need 3 equations with 3 unknowns. Would I get the same answer if I use this guy? Yes. And so I chose those ones. I did my solving. By the way, I could have done an LU factorization. Didn't do it. Wouldn't do it. Wouldn't be prudent. And so you had 1, 2, and 1. Well, come back up here and look. Does that make sense? Well, yeah. You got 1 amp coming this way. You got 1 amp coming this way. Together they form 2 amps coming this way. Yep, makes perfect sense. Does it match up? Sure does. Can these still be gross? Sometimes they sure can be. Sure can be. Even if you didn't know which way the currents were flowing, wouldn't be a big deal because the signs would take care of themselves. We just know. Let's see. You'd have to. You can do it. Yeah, I think you have to establish a direction. Yeah, I think I've seen it before. I don't know. Again, not an electrical engineer. They have computers that do this for us, obviously. But if you're just analyzing a system, that's kind of how you'd go about that. Okay, so this is a traffic flow pattern. You can think of it as water, traffic. Doesn't make any difference. What has to happen at the nodes is obviously at A, what has to happen is you've got 20 coming in, obviously, and you've got F1 20 coming in, you've got F1 and F2 going out, and obviously that better equal 0. And at B, you've got, well, it looks like you got F1 and F3 coming in. You got 25 going out, and again, it better equal 0. And of course, if you want to have F1 plus F3 equal 25, you're certainly welcome to do it that way too. At C, you've got 30 coming in, and you've got F3 and F4 going out. And you get D, so you got F2 and F4 coming in, and 25 going out. Okay, that's 4 equations, 4 unknowns. Baby, we're off to the races. Let's just make this look better. So F1 plus F2 better equal 20, and F1 plus F3 equal 25. F3 plus F4 equals 30. F2 plus F4 equals 25. Now, if one is smart when one does this, one will do it thusly. Now, I have never been one to be known for being smart, so don't talk to me about your issues about things, because I'm not. This one I'm going to put on the bottom. It's fewer zeros to make. Oops, 0, 1, 0, 1, you idiot. No, yes, and 25. right? Correct. So I just flip-flop those bottom two around. Okay. So let's do a little R1 minus R2 action here. Come on, shrink it. Shrink it. Give it to me. Oops, maybe not that much. Maybe. All right, so let's see what we got here. So the top one didn't change. 0, 1, -1, 0, -5. Cool. Now I've got my zeros here, 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 here. 0, 1, 1, 30. By the way, could I do an LU factorization on this one? Yes. Would I want to? Not particularly. Here I'm going to do a little row 1 minus row 2 action. Looks like. Again, right? And interesting. And well, actually, yeah, row 1 minus row 2. That'll give me a 0 in the top row. And then row 2 minus row 3. Give me zeros here and here. All right, let's have some fun. So 1 minus 0, 1 minus 1. 0 minus minus 1 is 1. 0 and 25. Cool. Didn't touch this one yet. All right, so 0, 0, -1, -1, and -30, I believe. Yep. Nice. Cool. All right. Now, remember, we talked about this before. I know I did this problem before. I did one similar to it. I know I did. Because I know what it was. Is when, yes. Oh, yes. Okay, so anyways, this is another example of one where you would think this would have a solution, but it doesn't. Because clearly if you take row 3 plus row 4, you're going to get zeros, yes? Now, what does that tell me always? It always tells me that there's multiple solutions, but that there is going to be some proportionality constant at play. And so, like, one is going to be twice as big as the other and things of this nature. So we know that F1 plus F3 has to equal 25. And we know that F2 minus F3 is -5. And we know that, I'm just going to write this as F3 plus F4 is equal to 30. Those are our conditions. Okay? That counts for everybody. Now, if you think about this, well, let's go back to our deal here. Oops, let's write the answers. F1 plus F3 is 25. F1 plus F3 equals 25. F2 minus F3, I'm actually going to write that as F2 equals F3 minus 5. Okay, and, I probably should have written it differently. That's okay. I'll do it that way in a second. And then F3 plus F4 is 30. F3 plus F4 is 30. Now, they all have an F3 in them, yes? So F3 is equal to, so because they all have an F3 in them, I'm going to write them as F1 is equal to 25 minus F3. Okay? Clearly, the biggest that F3 could be, the biggest it could be is 25, because that would force F1 to be 0. And of course, the less it could be is 0. Okay? Now, be careful. Hold your horses, because F2 is equal to F3 minus 5. Okay? Well, what does that say? Well, if F3 was any smaller than 5, we'd have a problem, correct? Because if it was like 4, then F2 would be negative. Now, big problem? Not really, because technically it would just mean that F2 is going the opposite direction. Okay? But if you want to force F2 to go the way that we say it's going, then F3 must be bigger than 5. And then, of course, F4 is equal to 30 minus F3. And again, if you insist on F3 and F4 and all of them going in the same directions, then obviously you're like, this one says that F3 could be as big as 30. Well, not so fast, because if it was 30, this one would be negative. Okay, this is our restrictions then. Okay, so then let's just pick a number then. So for instance, let's say that, well, okay, if that's true, then what does F1 do to us? Well, F1 could be anywhere from, it could be 0. When would it be 0? It would be 0 if F3 was 25, and it would be 25 if F3 was 0. And then what about F2? Well, F2 obviously will be pinched between a couple of things. So if F3 was 0, oh yes, here we go. So yes, yeah. So yeah, so we said, oh, that's right. So that's right. No, when we pinched F5, that's right. Smallest this could be is 20. Sorry about that. No, I had that right the first time. Stupid. The biggest this could be is 20, because the smallest F3 can be is 5. Forgot about that. So F2 could be 0, and it could be a maximum of 20, because based on that. And then F4, well, you would pinch him between 25 and 5. Oh, I did it backwards. 25 and 5. Again, there's a multitude of possible things that could happen here because we don't know anything. There's just too many unknowns. If you said, hey, let's let F3 equal 7, then F1 is 18, and F2 is 2, and F4 is 23. Done. Okay. Again, a variety of ways to go about these. Another example was the chemical equation balancers. So aluminum plus whatever that is, I forget, equals this. Cool. Plus some hydrogen. Awesome. Whatever. Cool. So this is a molecule, right? That's a molecule. Cool. Clearly, whatever I have on this side of this, I have to have over here as well. Okay. So let's see what happens here. And then for every one of these dudes here, you get 3 of these guys. Okay. And then, so yeah, let's figure it out here. So this one's really boring, so that we know that for this, we have 1A has to equal 1D, let's say, right? It has to. And then for H, this is B, and I don't know, big fat E, I guess. We know that those, so B is equal, or 2, B is equal to 2 E's, right? Because for every one of these, you get 2 hydrogens. And then for these guys, you're going to have B is equal to 3D. Okay? Ouch. Because A equals D, technically we only have 3 equations here, or 3 unknowns, I guess, is the way to write that. Technically. So that's why this problem, no, B equals, no, so A equals 1, 2, 3. Yes, I do need A equals D. A equals D. A, B, C. Let's think about this for a second. Hang on. I think the other one was too easy, and that was throwing me off. Which I know sounds weird, but there it is. I don't care. I'm going to roll with it. I'm going to use D. I'm going to use E, F, and G, I guess. Okay? So let's do this. Let's talk about our carbons. So 4A plus C, or plus E rather, I mean, plus F. Well, no, plus, minus those guys. Well, has to equal those two. That's what I meant to say. I was going to say minus equals 0. That's I'll do that later, I guess. And we also know that 10A for hydrogen is equal to, the only hydrogen we got over here is 2 G's. And then for that chlorine or whatever, that's 2B is equal to 4F. And who haven't we talked about yet? Oxygen, I guess, huh? Oxygen is 2D equals G. Oh, no, equals 2E. Almost forgot about my carbon dioxide there, plus G. Okay, and so what do we got here? Do we have what we got? So we got carbon, we got hydrogen, we got chlorine, and we got oxygen. And that is all she wrote. Okay, good. Yeah, it's fine. It's fine. All right, something to look weird about the other one, so I don't know. 4A minus E minus F equals 0. 10A minus 2G equals 0. 2B minus 4F equals 0. 2D minus 2E minus G equals 0. Okay. So let's do A, B, D, E, F, G, like that. So 4, -1, -1. And let's do 10. Oh, okay, so we're back to this. Again, we'd like to clean up this. So I'm going to do 10R1 minus 4R2. So it's -10, -10, and then 8. Oh! Shoot. Idiot. Try that again, dummy. So I am multiplying. Yeah, so I'm not multiplying. I'm not doing the top one at all. I'm just rewriting it. There we go. And then I'm going to have 0, 0, 0. And then I'm going to have -10, -10, 8, 0. Holy mackerel. 0, 2, 0, 0, -4, 0, 0, 0, 0, 2, -2, 0, -1, 0. Nice. Now, clearly, this one, I'm done with this one. Okay, there's nothing I can do with him. Okay, I will not be able to clean that up at all. I won't be able to. I'm going to use him to get rid of these guys in a minute. Okay. Cannot get rid of him. I'm stuck with him. So, yeah, I am going to play musical chairs and slide this one up. Oh. Shoot, I should have missed those bottom two around too. Sorry, let me fix those. I'd like to get as close to reduced echelon as I can. Wait, what are you doing? Oh, yeah, that's right. Keep going. I'm getting confused. Cool. All right. Wow. Finally. Okay, so would really like to get rid of, for instance, this guy and this guy, perhaps. Okay. Let's just see what happens here. So how am I going to do that? I think I am going to take 2R1 plus No. Minus R3, right? 8, 0, 0. It's going to be -2 minus a -2 is 0. -2 minus 0 is -2. 1, 0. Okay. And then let's get a 0 here for grins, shall we? And so let's do a little 5 R3 minus R4, I guess. So 10 and 0 and 10 and -5 minus 13. Yeah, I guess. Oh, darn. Nice. Okay, good. Okay. Okay, so I got zeros there. Okay. Notice that this guy, I'm stuck with him. Yeah? There's nothing I can do with that. I can't get rid of him. All right? Could I get this guy back to being a 0? Well, if I did, I'd put something back here. So I'm pretty much done with that. Now, question. Can I get zeros, for instance, though, here? Can I get a 0 here? Or can I get any other zeros anywhere else? Yeah, not really, I don't think. Because as soon as for instance, when I get here in a minute, it's going to be kind of a mess. So there's really not any further I can go on this problem, I don't think. So... all right, so the last one, I don't know. I'll come back to it maybe in a minute. I did this nicer, easier one for whatever reason. Zinc, sulfuric acid, whatever the hell this is. I don't know, whatever. There they are. Put them in the font, put them in the deal. Row 1 minus row 2 gets me here. Okay, so I clearly am stuck with this guy, right? I could move him up. That made me happy. I don't need to. But now I really like to get rid of, the only one I can get rid of really, which is this guy right here. If I try to get rid of this guy, I would be introducing this back into here again. So the only one I can get rid of is the one extra one here. So I did row 3 minus row 2. I got this. What does that say to me? It says that A is equal to G, which we already knew, by the way. It says that A is equal to P, or G is equal to P, which, by the way, we already knew as well because A equals P and A equals G. And then here we have that 2B is equal to 3P. Is that right? 2B is equal to 3P, which is, yeah, basically what we have here because we could have used a substitution problem right there. And then there we're off to the races. So, for instance, since everybody, not everybody, I guess, well, kind of everybody is P, let's just let P be equal to 1, which means G is 1, which means A is 1, and that forces B, oh, shoot, darn. Let's make B equal to 1. That makes these all 2. How about that? That makes sense for you? No, it doesn't. So 2B, let's back that off again. 2B, so if B is 1, let's do that. B is 1, then that makes that 2, so then P is 2/3. So P is 2/3, G is 2/3, and A is 2/3. Yay! And the crowd goes wild. You're like, I don't want thirds, Jay. Okay, cool, then times everybody by 3, right? So that would make this 2. That'd make this guy 3. Ta-da! We're done. Okay? I'm going to go back and look at the other one. I'm going to pause you while I do it because I think I was close and I realized I made a boo-boo. I think the reason that I was running into issues with this one is because there's really nothing to do, okay? You wouldn't want to touch either of these two because they're down as low as they can go. You're like, well, that's cool. Well, what if and of course, I can't add this one to this one because nothing's going to go away. And you can't add this one to this one because nothing's going to go away. Now, you could add the third one to the top one, but by doing so, you would be introducing either this one or this one and that's not helpful. And so that's what I was doing wrong. I didn't think that through, and of course you wouldn't have the bottom and the top either. And so that's as far as you can go, and then you guys just have to figure it out from here. In other words, this is basically as far down as you can go, and then you're off, and then you're just there, and that's the best. That's the best that you can hope for. Yeah, doing it this method. That's not very helpful for this one, unfortunately. That's why I was having an issue with it. Makes sense now. I just wasn't seeing it a second ago. Pause one more. And this is just number 2. So talks about bacterias. Again, it's just an application, and I don't know that it's helpful at all, but whatever, we'll do it. Bacteria 1, 2, and 3. This is how much food they eat per day of each kind. And then for A, there are 400 units available a day, and B, there are 500, and C, there is 600. So we know, what we don't know is how many X's, how many bacteria 1s there are. I don't know. So I know this, that X1 plus 2X2 better equal 400 because they ate all the food. 2X1 plus X2 plus X3 is 500. And then X1 plus X2 plus 2X3 is 600. And you all you gotta do is solve it. Okay. Again, not terribly difficult problem. It's just a matter of, trying to see how it's kind of set up. As far as that goes, I think that's pretty much the ones I assigned. There's more in that book, in that section, but it's nothing that I don't think that I assigned. So this is kind of where we're going to stop, I think.